idea is like the automation of self-designing systems in engineering.
Before lunch, my name is Nicolette Leijman. I'm a professor in industrial management from the University of Sweden. I will chair this session. And I hope you have enjoyed the presentations yesterday and this morning. Many of us are probing into contemporary and maybe even future-oriented phenomena. What we're going to do in this plenary session is to look a little bit in a historical perspective. And maybe I take your case by now, but Dora said, well, in our presentation we're going to tell you all about the K in CK theory. We have two presentations on schedule. First by Sub and Dora on the search of a theory of collective engineering. And then we will continue with John, who will tell us a little bit about science computing and cognition conferences. So, I think you are starting. The floor is yours, please.
Thank you very much, Nicolette. Today, what you are going to see, both from Europe and I, actually the journey started in 1980. When the Engineering Design Research Center at CMU was set up. As John said yesterday, because the heydays of expert systems and AI and everything, there was a gentleman from Westinghouse who came to us and said, what you are doing is not engineering. And that's what got the journey started for us. And you will see why that journey took us all over the place in search of theories which we need, multiple theories which we need to address the problem we were addressing. It ranges from economics, computer science, to mathematics. And you will see that journey being laid out in this lecture. So, just to set the stage, I mentioned the Westinghouse gentleman. The name was John Gallagher. He brought in a team of control engineers and several other people, which I will explain in a bit. We were already a team of cognitive scientists, engineers, scientists, nuclear engineers, and so on. It started as a multidisciplinary space right from the beginning. So I'll set the stage and I'll tell you about engineering-related projects, and Yoram will talk about PSI and closure. So you see, most of the things at the time we were dealing with, thanks to Simon, it was all very individualistic notion of cognition. Because most of Simon's reaction was to the economic notion of optimization and satisficing, so most of it followed methodological individualism. That was the primary focus of artificial intelligence. And here we were in the world of artificial intelligence, at the birthplace of artificial intelligence, and suddenly we are told that's not what we want to look at as engineering. Here is the path we want you to take. So it was really local. I was introduced to ethnography by an engineer, not by a ethnographer. And I believe engineers, reflective engineers, are actually sociologists underneath, because they have to deal with the sociology of the world as well as the technology in such a way. And that is how we got into it. Then I'll talk about industry before globalization, and you will see what globalization did to the notion of K. What does it mean to manage the K in a global situation? Then I'll talk about a little bit about the fact that it was object-oriented technology was rising with Smalltalk and so on, an expert system and early AI. And our group itself was very diverse with lots of different people from philosophy, social science, engineering, computer science, and gypsies like me who kept traveling between discipline to discipline over time. So this is how the journey goes. Just to give you an idea, we started with thermal and nuclear power plants, which are the most demanding engineering tasks in the world. Every item has to be recorded and justified for posterity. Where the K which is produced has not only got to be documented, also has to be documented as to how it was produced and how it was verified. This happened in aerospace too, but nuclear is even more rigorous from this point of view. Then we got into integration of material labs at our core. And then we got into globalization. ABB was the first company to think about what we call being local while being global, where you have a core and you do the variation. That was the beginning of globalized consolidation of knowledge and production. Long time ago, Armand told me that I was tracing the history of industrialization through my projects, and that's what you are going to see. And the same thing happened to power tools, and then we came to airport trains, and then standards. Without standards, we cannot scale anything. Okay? So I'm still working on standards. When we spent time in India, I spent time in India with my partner, where we went into public policy and really realized we have to deal with people who are illiterate, semi-literate, and how do you bring them to think about infrastructure? That's where games and simulations became part of the process of arriving at requirements for different things in the social context. And then we have done some more from a mathematical point of view, coming to category theory of foundation of systems, and then standards, which we presented last year, where we are mobilizing theories from linguistics, speech act theory, discourse theory, semantic network. Eventually, everything is language. What I say to people is when you breathe, you don't realize you breathe unless you go to a meditation class or yoga class, where people tell you, you know you breathe? Oh yeah, I do breathe. The same thing happens with language. We use it all the time. We forget language is the glue of the collective. There is no collective without a language. And Thomas Suttle from Italy, in Italy in cognitive science, he has done a wonderful pieces of work along these lines. I'll leave it at that, you can talk to me later. Okay, so we have these variety of cases and personal cases coming from different places. All of these things from practice, we kept looking for theories to explain what is happening in practice, the phenomena in practice. Right? And we keep searching, okay, this one explains this, but there is something else missing. There's something else missing. And the beauty of what happened was as we were doing this, new theories were being developed. From individual cognition to situated cognition to distributed cognition and so on. So as we went along, we kept incorporating the theories that were coming out from different places because we didn't have the collection of theories to explain what we were doing. So we primarily addressed, I already answered, said some of these things, that addressing industrial problems was the focus. We had limited theoretical foundation. We realized that the collective in the large requires a lot of different theoretical perspectives to be brought together. Otherwise, it cannot be solved. There is no unified theory by which you can explain the overall phenomena. You can explain various pieces with the different theories, but not all of them. Most of our projects are 4 years long, starting from study to actual implementation with the industry. And in all of these, industry was a partner, both R&D and the production company partners in developing this. I want to show you this. This is what got us started. This is a nuclear power plant. The first theory we mobilized was Jens Rasmussen's notion of cognitive engineering. Going away from individual cognition to cognitive engineering was to blend man and machine in such a way that it is embedded in the decision-making model, the functional decomposition, the physical plant. As information is brought in, different pieces are brought in so that every task is taken care of. You have to remember that running a nuclear power plant is not just the plant. When something happens, the community has to be informed. The state has to be informed. The global community has to be informed. You have to build the entire informational structure to manage this. That was the problem. In fact, we worked on a problem of redoing the underlying information system from PDP-8. I know most of you will never know about PDP-8 because there used to be a company called Digital Equipment Corporation, and Sun had just arrived with Sun Workstations. They asked us to build a distributed computing system to support the decision-making model in real time. Okay. So here is a design problem to build an organizational information system which is operating at a very high, low to high time constants in terms of decision making. Here is the whole thing. If I may tell you something, you will be surprised. I was told, so I suppose it's not a secret, that Westinghouse reactors are at the core of all French nuclear power. Okay? I suppose it's not supposed to be known, but that's a separate story. Okay? Why did we go to cognitive engineering? It was a man-machine. Here is a machine, there is people, there is decision making, and this has to take place on a continuous basis. Other theories were we mobilized. We realized that designing is a social process. Again, language, discourse becomes very important. And this paper came out in '84, and it was really fantastic for the right time for us to draw upon which of this work. And then he said something. Then they themselves ought to be designed support systems, accommodate the different perspectives of user within the firm, the importance of exchange of object words. Every perspective comes with its own object words, its own cognitive space, and these have to be brought together. Ought to be taken into account. This points to durability, the problem of networking participants through future representations. That's where the dialogues take place, negotiations. At the same time, notion of different object words point to the need for flexibility of the tool. It has to evolve and has to be dynamic and to accommodate the peculiarities of the furniture users, users object words, own object words. Then we borrowed something from Goel's work, which is on invariant in an individual designer's work, short-term, simple system, solution, decomposition, etc. I won't go through it. This provided us the space for the individual, but this had to be transplanted into the context of the collective. Alcoa, we learned again, language is at the heart of it. People said, oh, build a single ontology to solve the problem across these. It will not work. I can tell you, it will waste billions of dollars. I know people have wasted billions of dollars, and it doesn't work because you can't force the analytical chemistry guy to use methods testing guys' vocabulary and the product testing guys' vocabulary. You can map them, find concordances, but you cannot unify them because the semantics of the same term, tensile strength, varies between 3 laboratories and it's not the same. So you have to understand that language and semantics is at the heart of it. So, okay, we built an integrated system with people in Alcoa, with engineers and their own R&D to actually build the first system. Unfortunately, Alcoa lost money that year, so they decided to shut off the project. That's life. Then we said, let's look at design itself. Where is the memory of design? This is outdated, there are more things that should be added. You can see everything from the social sciences, cognitive sciences, systems, morphological, computational. This is what we saw at that time. There is more to add to this. And design theories are contextual. Vertical memory is what we do in a particular discipline. But design is a horizontal memory. And it is blending different pieces together to arrive at something you want to produce. It is in that sense, horizontal memory is very important in preserving and sustaining them over time. Well, I won't go into it. We can talk about Farabend and Popper and against the method, which for us as engineers, what works is all that matters. I want to say something before this. We also built for Westinghouse. I don't know how many of you have heard of something called hypercard. In the original Mac, there is something called hypercard where you could link the cards. That is how we built the first imaginary system for multiple people. Then we built really a full-scale system with modeling languages, objects, relations, and operations. History and evolution of model was preserved. Individual spaces where an individual can work, and public spaces where negotiation takes place, and published spaces what is our standards. That's what you use as a frame for working together. And this was an distributed architecture. You can see we had an actual distributed system working, which we tested, used, and this became the way we built systems. Unfortunately, we didn't have enough money to build this itself as a system to distribute it to other people because it cost a lot of money to do so when we used it ourselves. Then we said, equations are not enough. We need informal structures which qualify the equation. What are the assumptions? What are the approximations we are making? And with the help of Yoram, went and studied history of shipbuilding and found out that early stages of design you use equations and later on you use data to bring rules. Now we are talking about data-driven, etc., etc. But this is a cycle which already existed in the practice of real engineering. Then we moved to the notion of socio-technical networks, where the notion of multiple actors and sub-languages with specific syntax and models. Zelig Harris from University of Pennsylvania, was actually Chomsky's student, advisor, said there are sub-languages in every discipline, and the syntax itself is differently used in different languages, which started us thinking in terms of syntax and language in different disciplines and inscription spaces. This is where multiple people are coming together, negotiating, putting their world of knowledge in such a way that they can negotiate. And role of classification is very important for communication. You need to communicate to classify, you need classification to communicate. Okay, this was our methodology. Study of practice, prototype, go through this process several times while continuously looking for theory This was one of our early systems to allow for supporting software development. And I'll go through it very quickly. That is the information flow, shift to globalization, variety within a common core for different markets, 7 globally distributed transformer and production, creation of common core. We implemented a system to capture design process, traceability from specification to design, and to be able to search previous history. And this was the architecture we used. This is one of the studies where we found that the knowledge was getting corrupted constantly because the communication patterns were broken. Same thing with Bosch. We built a system. They were not together. We had to bring them together because there were common parts across these different tools. So we need to figure out how to bring knowledge across these disciplines. And this is what we built, and you can see the paper, and we actually implemented, transferred the technology, and it was used by 2 or 3 divisions in Bosch. Of course, now they're modified. So these are reflections as we started doing, and then now we mobilized yet another theory, sociological theory of information spaces use. And we did something similar, but this is a more complicated. For trains, that is one person. Each person in the node is like this. Every line here is a real line, not imaginary. So this is engineering in the large. Okay. Systems models are local. We need to worry about global. Global, we must compose local models to arrive at global models which can be verified. Then standards, and standards are social memory. Without standards, we cannot scale, we cannot globalize, we cannot do anything. Without consensus, structures, and so on. In fact, my current work is in use with a computational linguist to look at how we can help development of standards. Then we spent some time in India, as I told you, because of literate and illiterate people, we had to move to the visual space for interaction so that communication can take place beyond the literate. And there are lots of projects we did along this. And then we moved to formal foundations where we saw that we didn't have sufficient mathematical rigor here. We only had graphs and graph models. That was not enough. That led us to category theory, the most abstract theory. Okay, you?
Yes. Okay.
Sorry, I took more than
2 minutes from the side.
What?
2 minutes from the side. Okay, questions. So what Sub said basically, in '99 we summarized this into this framework. So we had an infrastructure for the project that's composed of actual software and practices. And we use all these things as the way to start approaching a new project. And because we could do that very easily because of the infrastructure, we could address a new project. And then in this new project, we entered empirical studies, and we reflected on that, and we improved this all the time. And now I'm going to start from 2011. Don't take pictures, send me email, you get the whole presentation with all the clicks, and so concentrate on the so here, I mean, from 2011 and onward, it's not incomplete. Here you see the theories that were mobilized to evolve the PSI framework. And I have to start telling you what the PSI is. So it's a very simple model in my view. The most important model of this framework is the PSI matrix, and it's a 3x3 matrix. We usually think of that. This is the product, this is the challenge that we want to address. Very little we think about who is actually doing the work or is involved, like stakeholders, design, and so forth. And we some worry about the processes. We usually have a vision where we want to go, but the vision has to also be designed by somebody in a process. And if we have vision and we work in our operation, we need to think to make sure that the vision aligns with what we do, or what we do aligns with the vision. So this is a reflection level, and these are very important people because they look around and see if everything is aligned and working appropriately. So in 2011, basically we sat down and used some of the theories that Sab mentioned, like situated and distribute cognition and boundary object and so forth, ethnographic study. And we try to map them into a new space with 3 axes, and you see them basically situated in the space. And we came up with the S-space. Now, the reason that we want to share with you the theories that were mobilized in the process is because when we develop any artifact, we use multiple disciplines. And similarly, when we develop a design theory, the theory itself as an artifact requires mobilizing multiple disciplines, multiple theories. So we are going to continue to show you these theories. I won't dive into them because we don't have time, but here, this is the theory, okay? This is the design theory, and in order to create a design theory that actually explain how design object come about, we need all these theories. So at the end of this, we basically generated the S-space, and we formalized the PS as the initial state of the PSI framework. So to be consistent, we model the process of designing PSI with PSI, okay? So we were here in 2011, Sab, me, Frido, and Sebas, and we had dialogue and synthesis of our experiences, and we wanted to understand design, and this was the state of the understanding. Most people talk about the product, few talk about the people, and few about the processes like the V model or systematic design. And the end result was that we had now P and S as we think defined, and we didn't take much care about the I. And we defined design, but I won't go into this. When we analyze the situation with PS framework, we did it textually, okay? We didn't have that box yet, the matrix. We didn't have that representation. And then in 2012, Sab presented the economic development, and then a year later we came back and talked about CS games to design institutions, and from these 2 studies came the third space. And these are the theories that were mobilized to understand what the institutional space is and what should be in its representation. And you see it there. So ultimately now we have the PS and I, but just one layer, the bottom layer of the PSI matrix. Okay, and again, this is, we were here, and dialogue and synthesis of experiences. We wanted to understand design, we mobilized CS games and other economic theories and so forth, and now we have this in place, okay? One important aspect to understand that when we model now a situation, it is placed in these 3 spaces, okay? And when it moves from one situation to another, it moves in the space. So if the problem is different, probably the people who are involved will be different, and the processes might also be different or should be different for it to succeed. In order to understand how we design new institutions, we mobilize here CS games. Now we speak about the digital twin, so this is human twin, because you abstract from reality, you put people in a situation of a game, in a situation that is unconstrained and let them do whatever they want, design the institutional, their organizational work as they want. And in this way, we get new ideas how to design the organization that then need to be implemented in reality. So that process we called alignment of the spaces. And in sub to show you information flow studies, that was the ending way to do alignment in our serious games, and we have more ways to do alignment. This alignment is different from the concept of alignment in management science, for example. This is a nice model, I think, of representing that. This is sort of thing, segregate equilibrium between the spaces. Again, I won't go into it, but we had now, the same thing, but now we added the alignment, which is a very important aspect of the PSI framework. And this is the type of ways or diagram that we use to explain how an organization moves from one situation that is not aligned to a situation that is aligned. And this is another example of how, let's say, startup company that starts with a very tiny object, ad hoc work in the garage. 3 people goes to becoming a multinational company. Obviously, different people, different products, different organizations, and they need to be aligned. Otherwise, it won't go all the way. Okay, and 2017. We were at a conference in Pittsburgh, and we drove to Sab's house in Washington, D.C. And George gave a talk at the conference, and I wanted to understand more, so I was sort of talking to him while Sab is driving, and here came the concept of the ethos. And we presented that, and this is the PSI depiction of that. So we are in the middle here reflecting on the La Défense metro station design, and George basically told us everything about the intricacies of success and later less successful ending of and wanted to understand that. So we came up now, okay, so ethos or vision of the project is here, and there are people involved in designing it in certain processes. And now the matrix is full, and everything here needs to be aligned. Okay, so it's quite complicated, but this is the PSI matrix. Now we went another step, and we wanted to look at the relationship between PSI and other theories, and obviously being here, we had a discussion with Dominique and Milena from SNCF about how to combine KCP or CK with PSI. So we came up with dual ways. PSI can be in service of CK, C can be in service of PSI, it can be from the inside, from the outside. So I just noted here, this is the way that CK can be used to align PSI spaces. But there are other ways to integrate them. The last point is in 2025, we published the PSI network. It took 6 years to go through. I said the conference presentation to this paper. Part of the time was to look at many others management science theories and to see what is the relationship between our work, how we differ from others, so we can sort of distinguish and also basically incorporate stuff from these theories. And now, this is, you see here the ending and all the other projects that mentioned, now modeled in a network of PSI, and you see all the boxes. Here, these represent different products along the way. These are different people who moved from the different organization, and this is the project. So the ending group and Westinghouse and the EDRC are 3 organizations. The project has a PSI of itself, mobilizing people from the different places, trying to come up with a single vision between all these organizations, which is not always obvious. So this is a representation. This is the representation of the La Défense metro station project, and this is what Sab mentioned, the ABP project, much more intricate. The paper has a clear description of this using these numbers. So it basically walks you through the whole thing, how it is aligned. So there is a lot of stuff behind it. Dreamliner is another interesting project where Frido and me and Sab basically try to analyze the failure of the Dreamliner. And the nice thing about it is that there was a process there where Boeing tried to fix the situation, but they didn't work it out. And at some point they did several things in parallel, and they succeeded. And when you look at what they did, this is precisely alignment of the whole matrix. So whatever they tried before was not real alignment. And so we can take this as a sort of external validation that alignment really works as we predict. Close to finishing. This was another presentation at the workshop showing the fractality of PSI. So PSI can be used in 1 to n layers. I presented 3, but it can be more layers depending on how you want. And each one of these can be placed in a network. And an issue in P, if you zoom in, can lead to another network. So you see here it's quite elaborate. This is a PSI representation of the whole thing. Okay, I won't go into it, but just mention that really what our vision is really to understand design and to empower people to improve and use the design capacity. So this is the guiding vision, and I hope what we do serve that purpose. Few things about applications, just you see the extent. So we use PSI to understand the residency matching market evolution of Alroth and some other people. And here we use four layers, but the top is missing. And then we did studies that documented research paper with PSI. And in our view, when the matrix was not aligned, it basically showed that the study was interesting, but didn't succeed in achieving its goals. I mean, there was a study that was published, but the goals stated initially were not met at the end. So, with this, I will urge you to try to use PSI to model your own research. And we took the same idea of analyzing research paper, trying to create best practices that can later be used to analyze sustainable communities. Same thing, it works. Communities that want to be sustainable, if they don't align their PSI, don't work. Some other things that other sustainability and let's move on. This is this is based on some analysis we did some time ago. We have many more papers. I teach it in class, so every year I have 40, 50 more examples of PSI. It's really a theoretical device to describe, analyze, explain, or change complex phenomena. It is a design theory. It satisfies the definitional property of a theory and can be used to formulate design experiments. In conclusion, what we presented basically is sort of an end-to-end description of being able to plan intervention studies to address real problems, till the use of NDIM, that you can actually design and build information systems that work in practice, and the closing the loop to reflect upon it and modify the theory as we go along. And because we claim it's a theory, we challenge you to refute what we say. I mean, really, we would love to be able to continue and develop it. So please do challenge us. and use it, otherwise we wasted your time, and you don't want to do that. So please model your research endeavor, papers, and life. I mean, it works for couples. Really, I mean, I can give you a presentation on that. But it works for couples. Alignment is very tricky with a psychologist. Thank you very much.
Thank you so much, so I suppose it's difficult to contain all the K in a presentation. There is little time for you now to refute what they have been saying, but I think there is maybe some time for a few questions.
What is alignment?
What is alignment? It's a very good question, because when two groups are working together, if there is no semantic agreements across, then you're going to make mistakes. What we mean by alignment is linguistic and semantic alignment between two groups. You don't need to know everything of the other group. You need to build a bridge language, as Peter Gallison talks about in the development of CERN, something called pigeon languages align in the border. And if these pigeon languages are corrupted, then failures occur, which is what we found in Atran's train system, because it went through mergers, all of these boundaries got corrected, both semantically and informationally, which led to 20% of the changes to be revisited because different parts of the company were not talking to each other. And not only that, Westinghouse had a notion of cognitive engineer who kept track of everything. He was fired, so everything was broken. And in these mergers, what people don't realize is they are doing violence, real violence, in terms of semantic alignment. And it takes 10 to 15 years to recover from it.
I have another perspective of alignment, because you have to make sure that the complexity of the task align with the complexity of the organization, with the complexity of the processes. You cannot design a space shuttle, two people working ad hoc.
Just it's really impressive. I mean, I want to reflect for the quantity of case studies and theories you mobilize is really impressive. I will have one question. Where is in your framework the evolution of project management practices? I mean, in one of your slides there is Clark and Fujimoto in a small bubble at the end of your framework, and there is over a period of study there has been important changes in the practice of the project management, like the apparition of heavyweight project managers, of co-localization, of concurrent engineering, which is also in the slide. So is it in S, in E, in E?
It's a combination of it with
Because
S and I.
it's typically the role when I say when it's alignment, one of the roles of the heavyweight project manager in Clark and Fujimoto is this one, is to force to deal to enforce alignment. So I think perhaps it deserves to be more present in your framework, but this is the question.
If you look at Bertrand Nicovert's paper on the study of CERN, he collected 15 years of notes and everything, and an organization. He finds different kinds of organized structures between 3 divisions or 4 divisions. Sometimes they are communicating with each other for getting them together. Sometimes there is a manager who is the translator. We have not we have not incorporated that part also, and you're right. There is a role of the manager is one of bridging these and identifying breakdowns in order to deal with them. We can talk more. I think Bertrand Nicovert's and Dr. Drew's paper is a fantastic paper. You should take a look at it.
Just comment to make this more concrete, let's say, the project management, practices, the way that you find sits in the I, the project manager sit in the middle, and also in the main guy sit in the middle, because he has to also evolve the project management practices depending on what's going on.
Thank you.
Yeah, my name is Emil Mazaran from Delft University. I'm wondering, you take us on this journey, now you look into organizations, and projects, etc., and you invite us to go into the relation. I'm actually working with an entire sector which intends to transform building and construction in the Netherlands. There's a vision at the top, there's a vision at the bottom. Do you have experience in applying this PSI framework on entire sector transformations?
Can you say that again?
Do you have experience in applying this framework on entire sector transformations? Like they intend to change, they have vast dominance in the K field, call it exploitation, whatever. They have immense difficulties moving into C exploration, etc. There's nothing organized there. But at organizational level, they manage. But every time the dynamics of the sector kind of puts, it's a knee-jerk response, but it flips back into what it was before. So have you experiences in that?
You have to remember, this is where the vision becomes very important. Percy Barnevik from ABB said, we're going to be global while being local. How do we realize it? This was a transformation of manufacturing. Earlier, things were dropped from west to east to the countries, right? Technology was dropped, as I said, somewhere. One of the plants in Kerala, which is a hot place, which was built, an aluminum factory built by the Russians, it has got snow roof. This is where contextualization, and which is something Barnevik understood for the localization. Okay, we can talk more about it.
And then so I think that the alignment within the sector becomes a sociology of the invisible. You don't know where the alignment is, because you're missing the overview.
Okay, there is. I cannot go into everything for you.
We just have one final question or remark.
Yes, the slide, which of course is the most challenging, is how we relate CK theory to PSI. And I think it's one of the major results of our work, co-work. And there it is interesting to see what happened. You came from engineering, but you didn't have a theory of collectives.
Yes.
We come from management, we had a theory of collectives.
Yes.
So that is very interesting. You discover the collective from your own history of an engineer which bumps the collective is a kind of wall. And every time it fails. What is interesting from the point of view of CK theory to say, hey guys, you are also fixed into special theories of the collective. So now we take PSI not as a data code, but as an open and known theory of the collective. And then, I don't want to contradict you, but it's very easy to enrich the model. Yesterday morning, Blanche presented the debate about justice. Where is the institution which is endangered or rediscussed in this?
Yeah.
And I'm sure you'll say, wait, we put it in, but we have to be precise. Academia. Academia as a producer of institutionalized theories. If you say to me an institution includes the ideology, includes what is called science, because by CK theory I can show you immediately that one of the resistance comes from theoretical economics. But you have to be precise and say, you put theoretical economics in the institution.
Yes.
You see?
Yeah.
If we do that, an alignment becomes interesting. So what I suggest is that you shouldn't present PSI as a kind of universal code,
No, it's a framework that can bring in whatever you want, basically.
But there, the wording differs. And the most difficult wording is institution. So I would like precisely to complete and say the PSI model invites not only to alignment, but to rethink, redesign what we mean by institution, redesign what we mean by social space. And there, we are perfectly not aligned, but consistent. And that is very interesting, that design theory helps to rethink theories of social systems. That's what I try to show. And there the agreement is not perfect in the sense we don't look for perfect agreement, but we avoid one trap, which is to say, let's take enforcing in set theory. If I say any new objects must follow set theory, it follows the axiom. If you say any new object should be described as P, Si, with the definition of P, of S and I, which I give myself, no, there we have a contradiction. So you have to say PSI are unknowns.
Yeah.
And we have to redefine them through the generative process. If that is okay, we have now a theory of design that includes both the design reasoning and the design of quality. That's a be a nice achievement, guys.
Yeah, I agree with you. Can you make a quick remark?
It's all right.
I agree with you.
No time